All right. Greetings. So let's begin our discussion of Unit 7, starting with this topic in a minute. And before we launch into talking about this, we should just give you kind of a big oversight about Algebra 2, right? Where are we in Algebra 2? We're still studying lots and lots and lots of different kinds of functions. That's like our goal in Algebra 2, right? Is to like introduce you to everything, all these cool functions. We did linear and quadratic and polynomial, and we did absolute value, and we're collecting the number of friends over here that we had, right? I've got the square root function now in my possession, and a cube root function, and log and exponents now we're good at, right? So now we're also going to study a set of functions called rational functions, which are important and useful. So this is not gonna, we're not gonna dive very deep into this unit at all today. Really the fun part of this unit will be when we get to like graphing these functions and all sorts of things like that. But there's not gonna be any graphing today. We're gonna start with things I think that you'll find fairly nice and easy for today. Okay, and this one slide consists of like basically all your notes today. There it is. Ready, go. Ta-da. And then we'll do some examples, of course. There's some things to unpack on this slide.
We're writing this down.
You should write this down. I know. I mean, I'm not forcing anybody. You can remember I'm recording this, so whatever you want to do. You can, the PowerPoint's on that line, whatever you want to do. Take a picture. But this is like the only set of notes we're going to give you as far as that goes. And then we're just going to do some examples. So when you see in a problem, and you will see this in a problem sometimes, someone will say, the variable y varies directly with x. Or sometimes we'll say is proportional to x, or something like that. Then right away, you know, you should be thinking, oh yeah, direct variation, and right away you should write down this equation off to the side, y equals k times x. And in all of these equations, k is some constant of variation. Here. Is that better? In all these equations, k is a constant. K is for constant. This k constant begins with k. That's why. Thanks, Marcel, for that really sincere contribution. Okay. And you will hear this. Maybe you already do hear this sometimes, right? Someone will say, the pressure of a gas varies inversely with the volume of the gas, or something like that. Then they mean this kind of relationship, okay? Or you might say the height of the candle varies directly with time, or something like that. Or the amount of flour. The amount of flour in a recipe is proportional, or it varies directly with, the number of people that the recipe serves, or something, right? You know, whatever. And then really, the joint variation thing at the end is not, actually kind of a special case of the first one up here, direct variation. In fact, you might even say, instead of z varies jointly with x and y, you might say z varies directly with x and y. Because it is, isn't it the same? It's like, look at the two equations. Varies directly, you just have like another y on there, right? Okay. And again, just to be clear, like we've done in other equations this year, x, y, z, those are variables. K is a constant, okay? So x and y are things that can change. K, though, is always the same number when we do a problem. Okay. You'll see. You'll see. It's just like gigantic. It's got like a. Everyone look at it.
Whoa. How do you tell time?
With his eyeballs.
Alright, sorry. I just been distracted. Are there any questions about this, or anyone still need a minute? You'll know what we mean in a second here.
Yeah.
These equations are important. Make sure you can identify them in the wild, right here. Can you tell from the form of the equation which one is direct variation?
Yeah.
Or which one is, or maybe not. Okay, let's be clear. If they don't come to you in that nicely prepackaged way, you may change the equation. You can rearrange things in this equation to make it like that. So we should say direct variation is when you have this situation, right? Direct variation is when you have this situation, y equals k times x. Or if you can make it look that way, right? If it doesn't look that way, if you can make it look that way, then you can convince yourself that it's direct variation. So, or what's the other one? Y equals k over x. Right, so these are your models here, or z equals k x y, right? These are your models. If you can make them look those ways, right, then we have direct or inverse or joint. So the point is, for A, this doesn't look quite like the things up there. Can you convince me that it's, well, which do you think it is?
Direct, inverse, joint.
Okay, well, this one's direct? Okay, if it says direct, or do you think this is inverse?
That's it.
This is direct, or what,
That's
justify yourself.
Inverse.
Multiply it by 5 and then it's just kx equals y.
Yeah, you feeling what Jocelyn's saying? So you multiply both sides by 5. Do you agree? We're going to lock you into a logical hole here, okay? Do you agree that this is equivalent? You who say this is inverse, do you agree that we can write this as this instead, that this is equivalent? Multiply both sides by 5? Yes?
Yes.
Okay, then I think that you have to agree with us now that this is
yes.
this is actually direct.
That means
Right?
5 is k.
Yeah, in fact, k is 5. Exactly. You're right. So this is direct, and maybe it wasn't obvious at first, but if you can manipulate it to get it into one of these forms, then you're done. Right? What about B?
Inverse.
Okay, convince me, because it doesn't look like any of the form. Again, it doesn't really look like any of those forms. Yeah, maybe divide both sides by x so that we get y equals 4 over x. And then I think we can all be convinced that this is inverse variation, okay? But again, both A and B kind of throw you off maybe. A is, at first, if you've never done this before, you're like, oh, that's inverse because there's like a fraction bar. Okay, well, don't be thrown off here. Or B, you might think like, oh, we're multiplying stuff, therefore it's direct. Well, okay, let's not be so naive, okay? And then the last one, you might have a hunch that it's joint variation, right? Because there's a z in there. Okay, so you're right, it is. But can you convince me that it's joint for sure by rewriting it in this form? Z equals something times xy. How would you do it? That is, I want this to be z equals, multiply both sides by x so that you get. All right, so then we'll get x, y. That doesn't look right though, huh? Sorry, my 2's and my z's are going to be easily confused here. Yeah. Is that good then? Actually, it's okay, isn't it? Because what's k? Right? Isn't dividing by 2 the same as multiplying by half? So in fact, actually, we can re-express the equation given as this equation. Z equals 1/2 times xy. So in fact, it is, we can actually make it look that way. Okay? So far, so good?
Wait, couldn't you automatically tell that it's
Yeah.
joint because there's...
Kind of, because there's a z, it's a giveaway, right? But it could be true that an equation has a z, x, and a y, and it isn't joint, right? I didn't do that to you because I'm not like that, but, right?
Yeah.
But you could have a z and x and y in there and not be able to do what we just did. Yeah, Jocelyn.
The three variations, like, what do they have to do with, like,
Rational function.
like, what do you do with those three?
Oh yeah, what are we gonna do with these then?
Yeah.
That's a good question. It's just for fun right now.
Oh,
Well, I already gave you a little bit of an example. I said, like, for instance, pressure varies inversely with volume of a gas, for instance. So there's an application. And we're going to be able to use that relationship to, if you know the volume, I can tell you the pressure, right? If you know the pressure inside of a chamber, I can tell you the volume of the gas inside. Okay. What about these? Same question still, right? I'm giving you some more exotic examples here. What do you think of D? That's tricky, Mr. Chase. What do you think, John? Am I getting one away? It looks like it's direct.
That's right, yeah, that's right.
Again, maybe I should have written those back up here again on this slide, right? So you got those nearby. Can you make it look, if you claim it's direct, then you better be able to make it look like that. Y equals something times x, right? So how would it be?
No, I think it's inverse because it's the numerator.
Well, why don't you give me some legal algebraic operations to do here? What do you want to do on both sides? How do you want to mess with this?
multiply by y.
Multiply by what? Multiply by 3. If you multiply both sides by 3, you get 9 over y equals 3 times x. You may do that, but was it helpful? No. Okay. Anything else someone wants to do?
Multiply by y.
Multiply by y. If you multiply both sides by y, you get 3. The y goes away here equals xy. Does that help us at all? I don't know.
And then you divide by.
Oh, and then you could divide by x. Oh, okay. Okay, Natalia. Okay. I see where you're going with this now. All right. What do you think of what she did? Is that cool? Can you do what she did? Multiply both sides by y and then divide both sides by x? Huh. And then is it obvious that it's inverse? Yeah. So if we can convince ourselves that this can be rearranged to look like that, then I think we've convinced ourselves that this in fact is inverse variation. Okay? Tricky. By the way, if you just look at it before doing any algebraic manipulations, you might just by looking at it be able to convince yourself that it's inverse. Because if y varies inversely with x, then x varies inversely with y. And the same is true with direct. If y varies directly with x, x varies directly with y. These are symmetric relationships, okay? So do you see that x varies inversely with y here? You know, maybe you could just look at it. But you're welcome to do what I did and do, we can actually rearrange it. E looks really simple.
What's a certain way that you want to rearrange it
To get one of those forms that we had on the previous slide, right?
to? Just any of those?
So if you divide
Any of them? Or?
Any of those. Well, once you get one of those 3 forms, then you're done. You're like, oh, I got it in the form y equals k over
Why is
x.
that form helpful?
Inverse. Then we know it's inverse. This is x and y have an inverse relationship. Right? It's like someone asking, hey, is this a linear relationship? Is this an exponential relationship? Or is this a quadratic relationship? Do you remember we just asked those questions about a table or something?
Oh, okay.
Yeah, so I'm asking, here's an equation. Which kind of relationship is this? Is this exponential? What is this? Right? It's a good question to ask. Yeah.
So if you graph it, does it look different?
That's a good question. Yeah, what does this look like if you graph it, D's? I think you'll be very, very interested and surprised. It looks really, really simple, but it's actually nothing you've ever seen before. It's crazy, right? And that's the kind of function actually in D here that we're going to be studying this unit. Carlos, you had a question. Sorry.
Oh,
No, not really.
there's 2.
Yeah, cool. There's something weird going on there. Yeah, Justin.
What do you mean by if y varies directly with x varies versus y? Like, this that just mean you can write it as a, wait, yeah, what is it?
You mean with the thing I said verbally a minute ago? Yeah. I said that if y varies directly as x, right, like that,
Can't say.
then you could actually divide both sides by k, couldn't you?
Yeah.
And you'd get this, right? Which shows me that x also varies directly with y, doesn't it? X isn't all, y is equal to something times x, isn't it? Well, also x is equal to something times y, isn't it? So they both have a direct relationship, one with the other, right? I know. The graph is cool. We are going to study that in depth later. That's like going to be our bread and butter later.
But how
Graphs.
there's two sides?
Graphs like that. Yeah, I know.
It's on both sides.
I have to right now leave that as a
Positive.
deep mystery in your mind. Sorry. But I want you to play around with it and you see if you can figure it out. For part E, I'm going to say none, even though it's simple. It's actually not something we can write in any of the three forms. So I don't know. I just thought we'd highlight that. That like it's not always true that something nicely always falls into these categories. For F, there's not much to say. Do you think it's joint? I think it might be joint. And what would it be? Z equals.
So you know what that is?
It looks good. I like it. Wow, 1 over x squared. Is that what it is? All right.
So
I've been around the block, you know what I'm saying? Okay.
You've been around the graph.
when you actually made it black.
You guys just, okay. Can you tell me on F, what would you, if we think it's joint, what would it be? Z equals, this is not one that's meant to be rocket science. What is it? Yeah, 3xy. Thank you, Chantel. At least someone's with me. All right. All right, I got one. That's good. Okay. All right, check it out. We got something else to talk about. All right, here we go. Let's keep moving forward. We're just, again, chipping the, what do I say? Just the iceberg, you know. Just the tip of the iceberg. Okay. All right, it says right away here at the beginning, and this is what I meant when you see the words inversely, right? It says the variables vary inversely, right? As soon as you see this, I put it in bold. I want you to think about which equation? Y equals k over x. Good. All right, so as soon as you see that, I want you to write that down somewhere. Boom. Okay, so we have the transmission from your word area of your brain to your math area of your brain, okay? All right, so this is what it says. It says use the given values here, x and y, to write an equation that relates x and y. And actually, if you've written this down in your thought bubble up here, then you've actually already done it. You've already actually written down the relationship, except we'd like to know what k is. Now keep in mind that k is a constant, right? X and y are variables. So what I've given you in A are an example of what x and y might be. If x happens to be 5, then y will be -2. You with me on that? Okay. Given that that's true, we can use those sample values to help us figure out what k is. What is k? Figure it out. Is it obvious to you that k is -10? We solved that equation by multiplying by 5 on both sides. And then, that's not what where we're done then. It says, use the given values to write an equation that relates x and y. So what do we write? Y equals -10 over x, right? Again, what do you fill in this box? If it asks for the equation, what do you fill in? You fill in k only, right? X and y are not 5 and -2. Are you with me on that? X and y are things that change. If x is 5, you can check, then y is -2. But what if x is 10? Then y is... What if x is 10? Then y will be -1, right? Yeah. Right, so you're with me on this? K is always -10 in this problem, right? X and y, though, are things that change. But at all times, the relationship between x and y is governed by this relationship right here, the inverse relationship. And then you do this one over here. Let's just have you do it. Ready, go. Shouldn't take long. Right? Go ahead. Come up with this. I want an equation that relates x and y. Again, they vary inversely.
Yeah, so
Maybe you can even after doing one, you already maybe have a shortcut, don't you? For figuring out what k is. All right, without showing any work, y equals something. Let's see. Someone have it? Negative 9 over x. Do you agree?
Negative 9.
I mean, this is the inverse relationship we're looking for, and we can verify that we're right by plugging in negative 3. Don't we get 3? Then we couldn't possibly have done it wrong. All right. Moving on to things that are more interesting. Trickier, maybe at least. All right. So now I'm being told the variable z varies jointly with x and y, full stop. So before we read any more, jointly, as soon as you hear the word jointly, that conjures up in your mind which of our equations?
Z equals kx, y.
Right, so write it down right away when you see that. Kxy. Yay, that's my thought bubble. Use the given values to find an equation that relates the variables, period. Right, so let's do that first, and then we'll return to the rest of this question. It says, use these values. Again, x, y, and z are variables. They change, but at one particular moment in time, if x is 4 and y is 3, then z is 24, right? So is that good information to figure out, help us figure out what k is? That's kind of our goal always, is to figure out what k is. 24 equals whatever, I don't know, times 4 times 3. So can you tell me what k is? Did you get 2? Get 2? All right. All right, then what is our relation? We still have not done this yet. It says use the given values to find an equation that relates the variables. So that's z equals 2xy. All right, so use the given values to find an equation that relates the variables. Finally, check. Right? Isn't that the thing that relates these 3 variables? Okay. Okay, Jocelyn, you're way ahead of me. All right. And then this is an equation that relates the variables, z and x and y, with this constant, 2. It's always 2. So then, yeah, now we can finally ask the last question. Then also please find z when x and y happen to be 2 and 8. What would that be? Z equals, when x is 2 and y is 8, Jocelyn. 32, right? 2 times 2 times 8, yes, which is 32. Okay? So actually that last question is kind of trivial, right? Once you've done this part over here, this is the big, powerful part, right? Once you have this relationship, you're like a god among men, right? Okay, go ahead, give me an x and a y, all right? I'm ready for you, right? Once you have this relationship, okay?
So z equals 32?
Or you're, god among women.
Goddess.
You're a goddess among women and men. And I don't know.
You're really cool.
Go ahead, Marcelo. How's the question?
Z equals 32?
Yes. Yeah. Again, z doesn't
Z equals 24.
z doesn't always equal 32. Sometimes z is 24, right? X, y, and z are all things that are allowed to change, right?
Oh.
The only thing that ever
changes when x and y
exactly
changes.
yeah. In fact, we might say z changes when x and y are varying, right? So we might say z varies with x and y.
K will never
Jointly.
change.
Got it.
K never changes, though, right? Well, I mean, in the next
Like
problem,
in
it will be different.
one
Inside the problem, though, K is a constant, yeah. These are deep mathematical ideas. Whew. All right. Again, same question. Here it is again, same question. I want to know what is, when x is 2 and y is 8, friends, what is z? Okay.
Don't we already have Z?
Well, I said when x is 2 and y is 8, what's z? This is, z is 144, right? When x is 8 and y is negative 54. But what is z when x is 2 and y is 8?
So we just have to find k first. And then
You might have to find k first, yeah. This is the same, yeah, this is meant to be a similar question. Last one here. Same instructions. Vote for Ratchet. Vote for Ratchet.
I don't know.
Did you read all this?
I like the other guy too. The other guy's a sophomore.
the other guy's big white dude.
Okay? And Ratchet
Well,
is
those
a rich
guys.
infant when it comes to Richard Montgomery. Everyone else is considered a minority. They were all Asian last year. That's minority.
Well,
Well, like in
It's not.
America,
It's
like,
not in America.
white people.
No, Asian is the majority.
How will you go
America.
based on their merits? That's insane.
I don't even pay attention. All I heard was every time the white guy, not the white guy, what's his name?
I fell asleep.
From BCC, he said something different.
I think we should read all this. All this. Have you read any of it?
Are you just saying Ratchet because he was Ratchet? It's Rashid.
No.
It's ratchet.
It's Rashid. He told people it was Ratchet freshman year because Ratchet was a cool word. And then he was like, it's actually Rashid, but I told people it was Ratchet.
Yeah, so what?
So then his whole let's get ratchet thing is
Let's get Ratchet. That's weird. That's dirty.
who says let's get?
He did.
Yeah, why are we doing this?
He did that in his video.
Oh.
You don't remember? He was like, in conclusion, let's get Ratchet. The hashtag makes you go like this.
Oh. Oh, pound. Oh,
Pound and hashtag are the same thing.
I don't know. I mean, I know that.
How's the problem coming?
Let's start it.
Oh, okay.
So, all you have to find is
Sorry,
K,
I'm distracted.
then you plug it in. To find what?
And then find Z.
What'd you get for K? Anyone figure out what K is?
Is it a fraction? A negative fraction?
I mean, I can't tell you, but maybe yes.
And so,
He's gonna get a joke. He's gonna get robbed. He's gonna get robbed.
Jennifer, how's that problem going?
Beautifully. I don't know what I was doing. I was gonna ask.
I'll cut it. What'd you get for K? Did you get negative 1/3 for K?
Yeah.
Z. Alright, so what is it? 144 equals whatever, I don't know what it is, times 8 times negative 54. And if you divide by those things, you get negative 1/3. Yeah, just convince yourself that that's what you get. Negative 1/3, okay. And then, so our relationship is z equals negative 1/3 xy. And if you plug in 2 and 8, what do you get? Negative 16/3, I hear you say. Yeah, when x is 2 and y is 8, right? That's what we get, all right? So you clear on what we're doing here? Are you loving this? Let's come out and interview the people. How's it going? You like this? Okay, great, okay. What did you say? Well, okay, so actually, like I said, this is actually the powerful thing right here. This is the thing, if you state anything, that's the thing I want to hear, because, you like that? Because the reason I think that this is the powerful thing is because now, with this in my hand, you come to me with any x and y and I'll be able to tell you what z is, right? This is a powerful equation. This is the thing that governs the relationship between x, y, and z, right? Right. So now, if x, it is also true, right? So, okay. You all right? What? Oh yeah, of course. Excruciatingly hard. All right. I got a table for you, and this is a trivia question, okay? What do you think? Is this joint variation? Excuse me, is this direct variation? Or is this maybe inverse variation? Or could it be neither? What do you think? How would you know? Stare at it for a minute and see if you can figure it out. What do you think? I don't want to tell you how to approach it yet. You tell me. Are you trying it out? A candy to the person who can tell me which it is and why they think so.
Oh, I got you. Hold on. I need my picture.
So wait, I have a question.
Oh, and I got fresh candy, man. Look at that.
Oh,
I
yeah,
have
so
a question.
That's good stuff. Well, that's true. Without apples.
actually, if you do like lime or lemon on them,
It's
something around,
inverse.
you know,
Yeah, for like a day or two. Eventually put it in my pack.
It's inverse.
You want to just leave us like that?
you snuck behind.
I didn't even see
You
you.
don't leave us, do you? Do you know how to do
I
it?
really need to
Go,
go.
hurry, hurry.
Right.
Would you don't let me go?
Right. Take up.
No, I don't want you.
Why?
Because,
How?
Anchor never does. Ever.
Yeah, neither do I anymore.
That's true. Keep up the good work. Okay, Jocelyn.
Inverse.
Why?
Because,
Wait, hold up. Jonathan did say it first. Do you want to justify yourself, Jonathan?
Yes, because as the X values get larger, the Y values. Now it's
Okay. I mean, I haven't said whether either of you is right yet, but go ahead. Justify
because
yourself.
when you plug it into the inverse variation formula, they all come out as the same answer.
Oh. Well, let's explore what she said, but she's right, okay? I know. Pretty excited. Yeah, so here's the way I would approach this. I would approach this by being naive. I would say, okay, well, I think it's direct. And until I've been proven wrong, I'm going to assume it's direct. Let's see if it's direct. If it's direct, then that would mean what? That 20 equals something times 1.5, right? If it's direct, yes? So what would that have to be? What would this have to be? That is to say, I think it's direct, and therefore I'm always multiplying something here to get this, right? So what would I have to multiply 1.5 by to get 20 is my question. So figure it out, tell me. 13 point something, right? All right, and then take that number, and it should work down here too. 2.5 times whatever you said, 13 point whatever. Is that 12? In fact, I don't even need a calculator to know that that's almost certainly not true. Right? Am I right? All right, so it seems like if we assume it's direct, we're very quickly shown wrong, aren't we? You understand how I'm kind of doing this? I'm thinking, okay, if it's direct, then 20 divided by 1.5, hear me out. If it's direct, 20 divided by 1.5 should be the same as 12 divided by 2.5 and 7.5 divided by 4. But even without a calculator, it's pretty clear that that's not always going to be the same number, right? Okay, so I don't think it's direct. Moving on, okay? If it were inverse, then it would be true that 20 equals 1.5, k divided by 1.5, right? So what would k be then? That is, the way we get y is by doing something divided by 1.5, right? How would we figure out what k is up in this equation? When you multiply by 1.5 on both sides? So 20 times 1.5, what is that? Isn't it 30? Okay. And then how would you check down here? You could check, is 30 divided by 2.5, is that 12? It does work. Okay, you'll see. Well, or you can just do that every time, right? So if you take them and divide them and you always get the same number, it's direct. If you take them and multiply them every time, and you get the same number, then it's inverse. And we just proved that that's true, actually, right? We just said that that's always going to be the case, right? If x and y vary inversely, hey guys, thanks for.
Wait, so you have to divide y by x. If
Then it
it's
should always be
direct-
true that these have the same product. And what is this? What is the product in all of these cases? 30. Yeah, 1.5 times 20 is 30. Is that same product here and here and here? Good. Then it's inverse. So the answer on this first table is it's inverse. And in fact, after our little discussion, we could even write down the rule. Right? There it is. Okay? It didn't ask us for the rule, but I thought, hey, why not? Let's write it down. So it's inverse. Is that clear? What we're looking for?
Yes.
And if it fails both tests, then it's neither. Yeah. So here's another table. Figure it out. What do you think? If you divide y by x.
Yeah.
What do you think?
7.
Again, same question. Is this direct?
This is direct.
Inverse or neither, and justify your
It's
answer.
direct.
We just give everybody a second to think, though, Marshall. But yeah, you're right. Okay, good.
Wait, and what's the second test? You add them?
No.
You what?
Yeah, pay attention, Marshall.
Lost track.
That's correct.
Wait, what's the second test?
Gregory.
Divide. And then,
What do you find?
what are you looking for? What are you testing?
I hear a bunch of people saying direct. I hear a bunch of people saying direct. Alan, do you agree? Okay. Why? Why? What are you looking for if it's direct?
Yeah.
Okay. You don't know. If you multiply, you get the same thing every time? So 31 times 217 is equal to 20 times 140? Oh, wait, no. What do you mean? What's our test for direct? If you, person out there, if you say it's direct, then what must be happening? What do you see, Logan? You don't have a say on this one?
Oh, you got divide it.
Well, I was asking Logan.
Oh, I got lost in the numbers.
Huh?
So I was kind of thinking that I was
Well, what do you think?
divided.
Dividing what and how did what did you get?
Like 217, 31. I don't know how to count.
Oh. Well, how about you do one of the other ones? What do you get? 145 by 20. 14 divided by 2. Yeah, 7. Is it always 7 is the question, right? Is 84 divided by 12, is that 7? All right, so yeah, this is direct. So we should write down that, and I think that answers the question. But we could also, because we just talked about it, we could actually also write down the rule. It's y equals 7 times x, right? Okay? So what are the rules again? I want to hear from someone I haven't heard from yet here. Oh, Brianna, what are the 2 rules? What are we looking for in the table as we approach this third one? If it does what, then what, and if it does what, then what? Uh-huh. And you always get the same number. Okay. Nice. Close one. So do it here. Try both tests, please, and tell me which one succeeds. Marcel, try both tests and see. Alan, try both tests and see. What do you get?
12. There's no constant.
Assume it's direct and prove yourself wrong.
It's not direct.
It's not direct?
It's not inverse.
It's not inverse either? All right, well then it's neither, right? If it's not one or the other, then it's neither. Okay.
What about the other one?
Well, it wouldn't be joint because we have that third column with a z in it or something, right? The question I asked originally was, is it direct, inverse, or neither? All right, last thing before we go. I know some of you are anxious to pack up and everything, but hang with me for another minute here. I'm going to pull some random names, for the first three here.
Oh, I gotta take my notes back.
A, B, and C are absolutely not curveballs, okay? I just want to be clear. There's nothing special about these. It's just to see if you're awake, okay?
Okay, wow. That's,
Let's see how you do. Because, I don't know. Are you awake? That's a good question.
it literally says direct inverse.
All right. Mitzi, give me the first one. Y varies directly with X. Right away you write down what equation? Y varies directly with X. What? Right away you write down what? Don't, Jonathan, nope.
I'm not telling you anything.
No, wait. I just mean there's an equation that goes with direct. Okay, yeah. Y equals kx. All right, we'll give it to you. Okay. Right away when you say direct, you write down Y. You see the word directly?
It literally says direct on the board.
All right. B, Jesse. Right away when someone says Y varies inversely with X, you think
Y equals K by
K over X. Very good. This is just testing you, okay? Right away when someone says Z varies jointly with X and Y, Nathan, what do you write down? Yeah. Z equals K times XY. And then what about those last ones? Those are the challenge questions. Carlos thinks he knows. Carlos thinks he knows. What about you guys? So good job, Nathan. Here, Z equals K times XY. What do you think, Carlos? Y varies inversely not with X, but with the square of X. Oh. What is it? It definitely is Y equals K over something, right? With the, what does the square of X mean? It doesn't say square root of X. It says square of X. So what is that? All right. Well, then no one will know. It's all right. It'll be a mystery for tomorrow. Okay. Good job. You are well equipped for tomorrow. We'll have to save some of the tricky ones for tomorrow. The next homework will be all right right now. Did everybody catch it on the board? Track and speed, right?
Yeah.
All track and speed. Only 18 problems. It's pretty quick, I promise. Bye, everybody.
The last one,
Good job. Bye, guys. Candy.